right, we are live, according to everything on my end at least. So yes, today or this month, we're going to be going through just VRVs or VRFs as a topic in general. What I really want to hone in on is some real high-level troubleshooting parameters, or not even parameters, but mindset. You know, there's a different, troubleshooting is troubleshooting, but there is a little bit of a different way that we tend to approach how we manage a VRV or VRF troubleshoot. And even myself, like I have a slightly different mentality when I'm walking up to that versus whether it be an RTU, a split system, or a chiller. Most of those others, I can use a lot of the same basic fundamentals and get a lot further and not have to really rework my mindset. But when I start walking up to a VRV machine, I know that I'm going to have to take a little bit of a different approach. And it's because of the fundamental design of what we're dealing with. It's using all the same science at the end of the day, but it's doing it in a different way. So anyway, one of the things I want to throw out there right out the gate, and this has changed over time, these machines have been getting more and more advanced. So having a laptop is fairly important to have access to, but it is not absolutely necessary. And something I really encourage you, especially if you're getting into the VRV side and you're having to try to learn what these things are, don't rely on the laptop, because honestly, there's a lot of more information in there than you will typically ever need on most any troubleshoot. There are some really advanced stuff you can get into where that laptop will be essential, but typically it's really not. So the manufacturers have gotten much better about building those displays into the machines, and that display will give you a ton of just really good information. And whether it be Daikin, whether it be LG, and specifically those two, Mitsubishi, I'm a little more fuzzy on. But the point is, some of the really critical stuff that you can pull up on the laptop, is it as easy? No, it's not. But if you don't have access to it, don't think you can't, or access to the laptop, don't think you can't get to the information. Most of it is in that display, especially like your temps and such, and your pressures. But you have to go, like for Daikin, for example, and even LG, you have to go into the service mode, which for Daikin is considered mode 2 or mode level 2. And then you have the function menus for the LG side where you tab, dip switch 5, and you can go through all those. So a lot of the troubleshooting, if you have the alarm code and if you have the manual, you should be good. And really try to go as far as you can. If you have the laptop readily at hand, that's fine. Forget everything I'm saying. Just go ahead, use it. But there's a mentality that I see where people get really hung up on the laptop thing, and I struggle with it. Granted, I didn't have a laptop for the first several years even available to me. I was several years into doing that type of work before I ever got to see the service tools for the first time. So maybe that's indoctrinating me a little bit. But the other thing I really recommend is you're going to need a decent meter. It doesn't have to be a really high-end meter, but I do recommend having a decent meter for this. Now, a lot of you are familiar. I carry a Phoenix G2, I think it is, and that meter will do fine. And you can do a lot of these types of troubleshoots, but I do recommend, so I have a filled piece bench meter that I pull out that's not my daily carry because I try to keep it, protected. It's a very good advanced meter that's fully manual in range. So with that, when you're having to go into some of the diode testing, or you're having to go into some of the DC side of the system, or just most of it's DC, honestly, that is where you're really going to benefit from having a good meter and understanding some of those base components. If you don't know, a lot of the time if you have an auto range especially, your diode test will be built in or will be alongside your continuity test. And you may even have to cycle modes on your meter but it should be represented by a little cross with a filled in arrow, something like that. And you'll have a symbol in whatever orientation it is. That is an indicator of a diode test. And part of what that's testing is how much voltage, DC voltage, is allowed to leak through the gates in the inverter, for example. So if we have too much of that voltage, it should be a set range. A lot of times, like 3.5 VDC to say 4 VDC, maybe a specific range that they're looking for. And if you're outside of that range with a diode, then it's very likely that you're having some kind of, whether it be a weak gate, you're having a leak to ground, something is happening. And then we use a ton of DC in these systems, and so your ability to read that accurately is going to be critical. The other really big recommendation I have is take it slow. Don't try to rush through these troubleshoots. Myself included, and the majority of the time when I talk to technicians and y'all are having trouble on these job sites, you're trying to hurry up a diagnosis on one of these, and you're always going to be fighting yourself in those situations. If you really just slow it down and really pay attention to what each thing is doing and really read through that manual. Many of the manuals, and I've got one prepped, I'll pull it up here in a little bit, we can look through one of the Daikin ones. Many of those manuals, there's a lot of information, especially on the flow charts, kind of packed into a very tight space. And if you're not reading really carefully, it's easy to overlook something, and you miss one critical step, and you're off in left field somewhere that you didn't mean to be. And it's just because you weren't taking enough time. So slow down. Don't get in a hurry. Don't get overwhelmed. Rolling beyond that, I really recommend pay attention to the alarm codes. Not everything on these machines is going to generate an alarm, but a lot of the time they will. And those alarms will go miles to help you sort through what's going on. And sometimes there are alarms that trigger that the workflow for that alarm will lead you to other problems. So let's say you end up having some kind of air temperature sensor issue or something along those lines. You start working through that issue and you realize that it was actually some other component in the system that was making that sensor do that. Now, majority of the time, if you just follow the workflows, or if you at minimum use the alarm code itself as a good starting point, you'll get a long way down the road. Now, in terms of those manuals, they are typically fairly easy to find, whether it be especially Mitsubishi, but even LG and Daikin. And then there's a few others. We've started having a lot more Samsungs, but all of these are relatively easy to get your hands on. But you have to be very critical in how and what you search. So, for example, an LG VRV, and we're not talking about even the indoor side. The indoors have their own manuals, and sometimes they will have a fairly decent alarm breakdown, but the manuals you really want to get your hands on are the outdoor unit manuals. That is where you're going to get from indoor and outdoor complete, like usually really in-depth. And Daikin, for example, does have a separate install and a separate service manual. And the vast majority of the time, you can just Google search and find that service manual. And now something else you have to bear in mind is being careful that you're not looking at a heat recovery manual versus a heat pump. Because if I'm not mistaken, they do separate those. Those will be two separate ones, but that also comes back to your model number. So usually it's the first 4 digits of the model. I'm trying to think. I know Mitsubishi, Daikin, and I'm pretty sure LG. You're going to base everything off of those first 4 digits. So like a Daikin is what, REYQ, for example, or an LG would be ARUN, or is that the indoor? Either way, the point is those first little bit, because immediately after that, you're going to see the BTU value very similar to a regular split system. So that's one quick and easy way that you can search and find the manual. Sure, you might have to go through a couple of different sites and be careful what you click on, but ultimately those things are available. LG does have a separation between install and maintenance and service as well, because I do have both versions of those. For our team in-house, anybody that's needing those manuals, quite a few of us have them. So feel free to reach out if you're dealing with a system and you need a manual for that. We should be able to get that manual to you without any issue. Moving on from that, another option would be to search very specifically the series name. So, a Daikin VRV 4, for example, if you search that and then put maybe service, don't put manual, or you can put manual, but if you just search that, that's going to give you a lot of really good results if you're having trouble with the model number. Same thing with the LG Multi-City. Nope, that's Mitsubishi. Multi-V. The LG Multi-V 4 or 5, I don't see very many 3s anymore. But you can search that, and don't input technically 5, they started using the physical number. But 4, they had the Roman numeral. So if you search that both ways, multi-V 4 Roman numeral, or just put the number 4, either or. If you have trouble getting what you're looking for with one, try the other. Those are other just effective options. Now, with Mitsubishi, they have a site, and I can actually share it here. One second. It is the MyLink Drive. Let me add it to the stream. Here we go. All right, so MyLink Drive is a fantastic website. Now, you see, here's part of what I'm talking about, P-U-R-Y. I would expect you should be able to search that and get the results you're looking for. I should be able to back up here. Oh, that's not what I wanted. I thought I was already at MyLink Drive. Maybe I wasn't. Let's do it. Do it live. Okay. So I'm going to search. I can get my search bar to work. MyLink Drive. Pulls up this and goes straight in. We're going to be in the USA. And then, so you have the M series, P series. Those actually have, so if you're working on smaller systems, those actually have graphical troubleshooting guides you can work through. But on the Y and R2 series, we can get into the actual units themselves. So now we can actually see all these different systems. So the only difference is between most of these is going to be the tonnage. So you can see the PUHY. Now, if we were to have just Google searched PUHY, I would imagine we'd start having manuals populate. Now, if we just do it directly through MyLink Drive here, we can scroll down. So there's your install manual if you need anything there. But then we have our service manual. So MyLink Drive, Mitsubishi did a lot to really invest in their system, and they've always been that way. From basically as long as I've been engaged with Mitsubishi in any kind of way in the field, which I guess it's been, I've been working on those 9 years. That's always been there from basically day one that I'm aware of. So, anyway, How are we doing on questions?
No questions.
All right. MyLink Drive, use it. Tech support. Tech support has gotten a lot better. I've found that you might have to wait some. I have less wait issues with LG and Daikin. Mitsubishi, I have had to wait more, but it's not always true. There have been a handful of times where I've gotten through to Mitsubishi relatively quickly. So just bear that in mind, that if you're going into it and you know it's a call that you've had trouble with, or maybe it's a callback, something of that nature, go ahead, put the call into Mitsubishi, maybe even slightly before you're officially ready. Make sure you're on site, make sure you're in front of it. But if you've got a couple of things to do, go ahead and try to get them on the phone, and while you're maybe getting things prepped, pulling panels, whatever it is you're doing, you can be explaining to them what's going on until you're actually ready to start doing the troubleshooting. Now, be careful of that, because we obviously don't want to become disruptive to their tech support chain, because the longer they spend with you, that's less time with other people. But the point is, factor that into your call when you're thinking about your time management and how you're going to structure approaching that system. That is going to be important, so that you don't end up having a tremendous amount of downtime waiting for them. At the same time, something I learned recently, if you do get on a call with them and they do the whole "we'll call you back" thing, let their system hang up on you. So I had a scenario recent. I went through exactly that. As it was telling me, "we'll call you back," okay, cool. I hung up myself, and I heard a weird sound that normally isn't there when I let the system hang up. And I've later figured out that I was hanging up as it was actually transferring me to the on-call guy, and I ended up killing several hours by my own doing. So learn from my mistake. Blue On has actually been able to give us some pretty decent support. I've gotten feedback from several technicians that they've been able to call Blue On and had a relatively short wait time, and they actually were able to help them make progress. Now, they're not experts on these machines as the factory would be, so but they can be a really good guiding voice, especially if, say, internally a bunch of us are tied up, we're busy, we're having trouble answering your call, or just getting to you in general, and you need another option. They're a good one to consider. We've had some very successful troubleshoots with those. One thing I do want to warn you when you're working on LG systems, this is just a mental note to make. If you're going to condemn, especially on their indoor systems, if you're going to condemn the blower motors, the control board, or the fan board, LG actually wants you to replace all of them together simultaneously. I had that scenario happen to me where we had we had a blower motor go bad. This was several years ago, and it was on a ducted indoor unit. Blower motor went bad. Tech support verified, they confirmed the diagnosis, got the new motor in, and it started generating other alarms. Well, then we ended up condemning the control board at that stage. So we went ahead, replaced the control board. Well, then the blower motor started registering bad again. We started having issues on the blower motor side. So by the fourth call out, I ended up getting on with one of the more senior level tech support guys from LG, and he was the one that informed me that they actually have an internal policy that anytime we start to change those components, that they recommend on a factory level doing it all together, because what they've seen is a bad blower will cause problems with the PCB or the fan board, and that will end up frying those components, even though they may not be the direct issue when you're troubleshooting. So then you go out and you replace that component, and exactly what happened to me, right? It turns into this chain reaction, and everything is causing everything else to fail. And that was the final solution. After 3 repairs, we ended up ordering all 3 components because it was a single motor blower assembly. Ordered all 3 components, and it was fine after that. System, to my knowledge, hadn't had a problem since. And we recently got called as a callback on a customer, from another vendor. They were having trouble with the same scenario. They ended up condemning the control board, and they did it through tech support, to my understanding. The other vendor did. They went back, put the new control board in, and the system was still having trouble, and it wasn't running correctly. So that is just, again, it's a pattern. It's very specific to LG. I've not had issues with that with Mitsubishi or Daikin. If anybody out there in the HVAC verse has any extra input on that, I'd be interested to see what you have to say. But I do just be cautioned. And I've also had similar issues with like doing the condenser fan motors. If one condenser fan motor fails on the outdoor unit, because you got to think, you have your inverter, you have your control, you have a fan board which is running the fans, and then most of the time we've got 2 condenser fans feeding into that. I've had it to where I had to replace both fans, even though maybe one actually failed. I've replaced both fans and that fan control board, not the rest of the system, but those 3 components, so that we prevented any further failures as we put the new stuff in. LG specific. Okay. So let's talk about some common faults. The 2 most common, and by far, I'm not going to sit here and go through every fault, but I do want to go through a couple of exercises, and I do want to go through a load charge procedure, what we're looking for, what we're going to, how we're going to troubleshoot that, and then say we're in a critical spot, we need to get this temporarily functioning until we get the leaks and whatever else taken care of. I want to kind of just share my thoughts on doing an active or a live charge on the system just to get them functioning intermediately. So the 2 most common faults that I've personally seen is going to be inverter or current overloads. That's going to be at the compressor typically. So several things could cause that. It could be an inverter issue. It could be a compressor issue. This is where you're going to really benefit from having a Megger on hand. To troubleshoot inverters, you're really going to need to understand diode tests and continuity and being able to read resistance properly through your meter. And I don't recommend doing these things in an auto range. Even if you have a meter that is auto ranging, you should have the function of being able to manually set those ranges. You're going to want to do that when you're doing these types of troubleshoots. If you don't, I've had personal experiences where I've misdiagnosed things because and this was my fault, but I didn't verify what my meter was saying and what scale it was in. So I read something, it was in the wrong scale, it didn't stand out to me, and I gave a misdiagnosis. So my point is, I really recommend using manual scaling. Anyway, so yeah, and I think I said input power. So let's actually go over here to one of my slides. So I've got a Daikin manual I'd like to share. Okay, hopefully, make sure y'all can see that. All right, you don't need me in the way. Let's go. Here we go. Okay, so let's say you go to you go up to a Daikin. This is a VRV 4 series specifically, and you're having a L8 error code. So this would be an inverter compressor overload, and so they give you some basic things. Detected current flowing through the power transistor when secondary side of inverter current exceeded. Decision made, application. So this is the model number. Again, if you're trying to find this manual, this is in the service manual specifically. This is on page 210 of this specific version. And the model for the system is a REYQ. So this should be the heat recovery, if I'm not mistaken. But you get this nice little flow chart here. So it really is just follow the chart. Take the alarm, follow the chart. Whatever the alarm says, even at the thermostat. So a lot of the times the alarms at the thermostats, they won't tell you what the alarm at the condenser is. Sometimes they will, or the outdoor unit. But they will lead you to check the outdoor unit. And so you'll have to take that alarm from the indoor, go to the outdoor, and then see what the code at the outdoor is, and then begin your troubleshooting from there. In my opinion, I would recommend your outdoor unit code overrides any other codes. So if you've got something at the indoor giving a code and maybe that leads you to checking the outdoor unit and it has a separate code, prioritize that outdoor unit's code first. Deal with that indoor unit code later, because a lot of the time it is the outdoor unit's problem that is generating whatever you're seeing at the indoor, even if several indoors are doing it, or say you've got 8 indoors and only 1 is giving you this code. That's fine. The code on the outdoor, fix it first. Sometimes that outdoor code will redirect you back to the indoor too. So anyway, we're going to go through this. And actually, I'm sitting here realizing I was just talking to the camera and I don't even have it looking at me. So there's that. It's been a day, guys. All right. So with power off, check and monitor mode are equipped with 2 compressors. So let's see. Is the stop valve open? No. Yes, stop valve. This should be the solenoids that control flow. Check the leads. And now, I will preface, if you're looking at this, and let's say we didn't know what the stop valve was. There are tons of diagrams and there's tons of information in this system. So we should be able to go to a search bar for this document, whether that's through the app you're using or in the web browser. I can go into the web browser menus and I have a find option. So stop valve, what is that? Why don't we just search stop valve. Now there's 37 accounts of a stop valve in this manual. And typically when you search, it'll highlight the words, and I'm trying to see if it highlighted it here. I don't currently see it. Let's cycle down. Usually they're highlighted. Well, this isn't the normal program I use. The one I typically use on my phone, for example, is highlighted. But we can look through here and we can try to see where our physical stop valve is. So we have check valve, electronic expansion, solenoid. Where is the stop valve? Right here. Stop valve with service port. So, okay, so the stop valve with service port, it's referencing the physical isolation valves, the little king valves or ball valves. They're just calling them stop valves, right? Are those open or closed? That's all they're asking. That's right there. That's what we pipe into when we first turn everything on and pull our vacuum from and everything else. So if you don't know, we can keep cycling through just to kind of see from experiment. So right now you'll see things changing. I'm just clicking on the arrows and it's taking me to all the different points in which it references. Now most of these diagrams, what you're seeing is different piping configurations or different modes. And so it was showing us if it's in heat mode versus cool mode. So now we land on this page. I really wish it highlighted. I didn't know. I'm not used to doing it this way. Anyway, somewhere on this page we have stop valve. So you get the point. It's a very effective tool. This is how I can quickly reference what I'm looking for, or if I'm reading through a troubleshooting guide. If I keep clicking here, I should get back to where we started. High pressure. So if you're reading through a troubleshooting guide, this is really going to help you identify what it is you're looking at. I know we were on page 210. I think this is it. It's 208. Here we go, back where we started. Okay. So yeah, stop valve is open. We can say yes. Check leads. So it's going to take you straight to the compressor, and it wants you to verify that the compressor leads are good. From there, are the leads in relevant compressor of the, are the leads of the relevant compressor normal? If you don't see any major problems, then obviously it would be yes. Are wire and wire connections in the relevant compressor normal? Yes. We move down to the next page. So it's going to take you through each of these things, and it's being very specific. It wants you to do these things with it off. So let's get down here. So check 4. All right. Is the power transistor normal? And check 4, we scroll down a little further. Check 4 is referred on page 251. So I can scroll down here to 251, so we're at 218. Almost there. Okay, so here's check 4. This is a service procedure. We're going to power off, remove all wiring from the PCB. You got your meter, and then this is our inverter circuit. So these are our inputs, our outputs. The UVW, that should be going to the compressor. We have our power in. So it's going to tell you that between all these different points, so between P2 and U, you should have this ohm value, 2 to 15,000, 2,000 to 15,000. So between P2, is that what I said? P2? Yeah, P2 and W. Yeah, right here. So here's P2 on this middle terminal. So we'd read between this terminal leg, this is with everything disconnected, and W, or U. There we go. So you would go through this process. You'd go through this entire check. If anything failed or was outside of tolerance by doing this check, then it's going to lead to just an automatic failure. Now here's that diode symbol I was telling you about earlier. So on the diagram to the left there, that's going to be specifically doing an ohms test. The diagram to the right is going to take you into doing a diode test. It is as simple as follow the instructions. If you have questions, maybe reach out to somebody who may be able to help guide you through it or talk you through it or look at this manual with you. So say we go through all this and it completely passes. Let's say a pass or fail. So we're going to scroll back up to page 210. That's where we started. Went a little too far. All right. On page 2. Okay. Did it check normal? No. Replace the inverter PCB. Did it check normal? Yes. Restart the system, and if the results reoccur, yes. So it tells you to replace the PCB anyway, and that's something that is absolutely real. You could go through these tests, and this is part of what it trips me too. I understand. Let's figure out how to use my program here. There we go. You can go through and do all of these measurements, and everything at the end of the day checks correctly. It does. Your meter doesn't read anything out of the normal. And it still have a problem, because at that stage, the problem isn't a direct solid state failure. There's things called EEPROMs, there's memory buses, there's actual CPUs that run these boards. And those things can get corrupted. Those things can have issues of their own. And it can cause these gates inside of the modules to not fire correctly. So that can lead to especially if a gate gets stuck open for too long or something of the sort, that's going to lead into a spike in current, and it's going to give you an overload condition. So those are just some of the little things, and it can get tricky. So just trust the manual, because at the end of the day, what you can do and what I do, I take the manual and I literally show it to the customer, and I walk them through it. Okay, this is the procedure. This is what it says. I went through all these checks and it said everything was good. I turned it back on. That was the next step. I ran it for a little bit, or it didn't run but a couple of minutes, and it immediately triggers back out and we get another trip. The manual says this is the correct repair. I need to go ahead and replace this before I go any further. That's all we can say. The customer doesn't have to be okay with that option, and they can get a second opinion if they want. You know, they're free to do that. But that is as far as we can go, because this is what the factory recommended. Anyway, I'm just give you legs to stand on. So yeah, and then indoor-outdoor communication faults. That's another real common one. I'm not going to take you through the troubleshooting chart on that, but these systems do have a lot of COM problems, and I see the most instability out of the LG side of it. In our next class I do plan to take a little more time and dive into the controls aspect and how some of the specifics on the wiring and how the whole harness comes together and just how the system communicates within itself. So the next one is going to be more controls oriented, not like building automation, even though that I guess kind of is part of it when you start getting into the like AC Smart or the iTouch Manager or the what do they call them? Mitsubishi's, the AE200s, for example. Anyway, it doesn't matter. They have their own name. They all got their own names. So let's talk about low charge. Yeah, we're doing okay on time here. I'm going to try to speed this up some. Low charge is really tricky to troubleshoot, but once you've seen it enough times, it starts to become more straightforward. But it will require the laptop. So this is one of those things where, like that overload troubleshoot, for example, at no point did it ever mention bringing the laptop out that I'm aware of. Double check that real quick before I make a. Yeah, nothing in here suggests pulling out the laptop whatsoever. All this is just a pure field troubleshoot. Okay? That's part of my point. You got the manual, don't really need the laptop all that much. But on a low charge, you absolutely do. So some of the things we're looking for, see if I get a marker that works a little better. Yeah, there we go. We're going to be paying attention to the EEV positions. Why aren't these drawing? EEVs. We're going to be looking at our superheats. Now, I don't understand. That one didn't want to write either. I wonder if there's something on the board. We'll try this. I did not fully clean this like I normally do. Yeah, we'll go with it. Our EEVs, our superheats, and this is our steps. So we can see physical steps on the EEV. Most of them are 2,000 steps, right? Yeah, 2,000. We're also going to be, we can look at our condenser fans and our compressor speeds. So if the condenser fans are ramped down, they're not having to reject a lot of heat. Our head pressure is down. Our compressor speeds are down. We have excessive superheats at several of our boxes or our fan coils. And our EEVs are mostly, if not all the way open. These are the symptoms you're going to start to see. And it's very likely that you may have, let's say we've got our bank of condensers on the roof. We're coming down. Let's just say this does not have a branch selector. It's not that fancy. My wonderful drawings. Okay, so this is our IDU 1, 2, and 3. Number 3 is the one that's going to show you the most problems first. So when you're looking at this and you first start these things up, you may see that, okay, at startup, they're all running about 200 steps, 250 steps, you say 300 steps. Okay, this is the EEV positions. So they're all running the relative steps, and let's say we're able to maintain, say, 4 degrees of superheat here, 6 degrees here, and this one's maybe 8 degrees. Okay, system ramps up, we have a load on the space, we're gonna start to accelerate and try to push more. That is not very contrasted on that. I'm sorry if it's hard to see or read. Anyway, brown. There we go. Yeah, now we're talking. Okay, we'll go with brown. So we give it 10 minutes. Now this is something you're not going to just turn it on and be able to get a diagnosis. You're going to have to turn it on, you're going to step back, and you're just going to let it run for at least 30 minutes. I mean, it takes that long, because this system, what it's going to do is it's going to slowly ramp, it's going to slowly build, and it's going to try to get that capacity. And part of what it can do is it'll store up enough of the refrigerant before it loads itself that it'll be able to kind of maintain, at least from the computer side, for the first little bit. But you'll notice that the longer it runs, these values are going to just slowly climb. And number 3 here will be the first one. So what makes number 3 is the furthest one on the piping run. That's what makes it number 3. Number 1 would be the closest to the outdoor units, 3 the furthest. So after 30 minutes, or say at 10 minutes, we were up to 1,000 steps. All right. We give it another 20 minutes. By 20 minutes in, we're at 2,000 or say 1,950, whatever it says at the time. I rarely see them actually hit 2,000. But anyway, and then the rest of these, this one may be 1,500 steps. And number 1 may be sitting at, 1,200, or maybe this is 1,750 and this is 1,500, whatever the case may be. You can even let it go a little further. The longer you let this thing run, 1, you're going to see your discharge air temps don't come down. They're going to stay high. And your superheats are just going to continue to build as well. So this thing may be up to 20 degrees. This one may be sitting at 15 or higher. Say this one's at 15 as well. And it's struggling. And again, your compressors aren't ramping. Your condenser fans aren't having to ramp because your head pressure is not there. All of this combined gives you an indicator, because these are extremely high superheats for these systems. Like, they run just a few degrees of superheat. Like, that's what they're meant to do. So to get positive 10 degrees of superheat, something's wrong. So you're going to see this system slowly kind of take off. And honestly, the most common way we find these, if the customer is staying on top of it, is this indoor unit here. Well, they'll just call in. Hey, we're warm. We're uncomfortable. Why don't you come check it out? The rest of them won't really be complaining because it hadn't hit them yet. So you'll come out to run the service call for this indoor unit, and you'll go through all the checks. There's no alarms, but you're having trouble getting your leaving air temperature to satisfy. And just the system's not maintaining. It's not maintaining. You can cycle power to it. You can do whatever you want, and it's just not keeping up. When you see that, some point in that process, it's going to lead you to needing to connect the laptop to figure out what is that specific unit doing. And then you're going to start to see all these other numbers in the process. That's going to lead you to giving a low charge diagnosis. There's not enough refrigerant in the system to maintain operations. And that is the ultimate problem. It's just not enough charge in there. So what these would normally be is usually I rarely see them get above 1,000 steps, if even that high. 500 is not uncommon to see on these indoor units when the load is under control. So when we're not talking about an excessive load or a pull down, when we're at set point and when we have a good charge in the system. Those valves don't have to open that much to maintain. Because that's the other thing you have to understand. It's a different concept. As I mentioned that in the beginning. So we're not trying to just fly to set point and satisfy it. No, these systems are designed to, like a plane landing. They're going to ease into set point and they're going to cruise right there at it. And so these valves and the leaving air temp, like it's not just an off-on type of operation. It's part of its goal is once it gets to set point, it wants to run extended period of time and just kind of hover there so that it's cooling as much as the space needs it to cool. That's why the fans is best to leave them in auto so they can vary on their own to match whatever the return load conditions are. And it's going to modulate its superheat, the valve position, and everything that it needs to. And the condenser is just responding to whatever is happening down here. Anyway, so this would be on a very just simplified level, a low charge. We can do a temporary charge. If you run into this, my personal rule of thumb, if we lose as much as 40% of that refrigerant charge, and it's a blend, so being 410A most of the time, we can't leave that in there, and I don't want us to leave that in there. For our team's level and perspective, we need to push that customer that we need to go back with virgin charge completely. Now, it doesn't mean the temporary, because if this is the case, we've got a significant leak. We need to find and fix that leak. We'll talk about that more in a second. But once we're done with the final repairs, whatever that looks like, we need to make sure we're putting into the job's budget a complete recharge of the whole system. But what you can do if you're going to recharge, because fractionization is the problem. It fractionates enough, and so if we don't take what is now the bad refrigerant, because that happens, if we don't take that out and we just put more in on top of it, that's not actually 410A anymore. Like the blend is so far off from what it's supposed to be, it's not going to behave like 410A. And these systems are so finely, precisely tuned that that's not going to work out well. It's going to dramatically lose efficiency and cooling capacity. Anyway, okay, so we know we have a leak. We found a leak. We need to get them cooling today. You're going to do that very similar to you would do any system. 410A, liquid charge into the suction line. You have to be careful. And this is going to be a very slow process. Now, there is a safer way to do it. The safer way would be to shut the system down, use your recovery machine to pump in a pound or two, depending on the size of the system. If it's a really big one, you may be able to go 3 to 4 or 5 pounds at a time. Most of the systems we work on, you should probably only go 1 to 2 pounds at a time, and that's it. And you would put that in on the liquid line coming out of the machine. So that's the safe way to do it, but you're waiting on the startup and shutdown time every time. A less safe way that requires a lot of caution, so just like we would charge a split system, and what you're looking for is you're watching for these numbers and these numbers, so your superheats and your steps to start coming down. And what you'll see, the indoor unit, the first one on the run, will be the first one to reflect the results. So say it's running at 1500. Let's say we got up to that high and we had a 20-degree superheat. You'll start to see it come down. It may go to 1000, and it's eventually going to work its way to 500. And it's able to run, 4 degrees of superheat. And then by the time this one's getting down to 500, You're going to see this second one in the series is able to come down to, let's say, 600, and it drops at superheat. And then eventually, the very last one is going to come off of that top end, and we can get it down to, say, 700 or so, depending on load. We can get that superheat down. This is going to take, if you do it correctly, a lot of time. This is not a fast anything. You're going to basically hook up to the suction, and you're going to add a pound at a time. And that's it. And again, we're not just going to throw it open and flood the compressor either. Most of these have accumulators, but we're not going to do that. We're going to slowly meter that charge in until we get the weight in we want to add. And then we're going to stop, and we're going to give it probably at least 20 to 30 minutes at minimum to let these numbers come back to their next state. And if they're still not where you like them, add 1 more pound. And you're going to do that, and you may be there for several hours doing this process. And that is something I do want to talk about a little bit when you're dealing with this, and when you're dealing with this, the customers, especially if they don't have experience with a building that has VRV equipment, they're used to service calls that run 1, 2, 3 hours, and you could pretty well do majority of what you'll ever need to on that machine in that short a time frame. And these calls, they do work out that way until they turn into this. These calls, this is just the temporary charge. This doesn't include the leak search. This doesn't include the repair and the getting it back online. Not if you do it correctly. Is there shortcuts you can take? I'm sure there is. But the leak search on this, you've got to keep in mind how many connection points, not only in each unit, but there should be isolation valves. Those are very common to leak, so ball valves. Those are common leak points. The flare connection points at the indoors, if they're flared, that's another really common leak point, even if they're not flared. And if you get there and the system's almost flat, because they'll do that. If I'm not mistaken, I think Daikin specifically, it'll run itself down to where it's only got 10% of its charge left before it will trigger a low or a charge loss alarm. 10%. That means you've lost 90% of your refrigerant, right? So you may get there may not be much pressure on the system to begin with by the time you're troubleshooting it. So you may have to add nitrogen, you may have to boost those pressures, and with a system like this, you're gonna have to really elevate those pressures to get that nitrogen and to make the leaks obvious enough. And don't just find one and stop, because it's rarely the case. Extremely few times have I ever had to do a leak search on these systems and I only found one leak. It may take you an entire day to completely go through one of these for just the leak search. So be prepared for that, and the customer has to understand that up front. And if you don't explain that to them, you're very likely going to start getting a lot of pushback because they don't understand the proper expectations walking through the door. And that's where we have to try to educate. That's something we're going to deal with. Let's see. Okay. Any final questions? We need to wrap up here. I got through everything I wanted to cover. I see we're actually right at time. Real quick questions. Have you seen anything come through? No? All right, I'm just going to scroll through our YouTube chat here. See, old Mr. Frylog down in San Antonio. He took 2 days to leak search, repair, recharge, and run a multi-splitty with 11 indoors, 1 branch box, 1 condenser. Leak was at 1 branch box outlet, leaving the branch box. Yeah, these systems get crazy, and there's actually it's been interesting. You know, I've talked quite a bit recently about how the VRVs are really pushing on the commercial market and really challenging what used to be either a large RTU or a chill water system. you know, the VRVs are a cheaper option, and so they're getting they've won a lot of those bids, and there's quite a few people that are saying that they're actually starting to go through, I think especially in Europe. I think some of those they were talking about in Europe where they're actually starting to go back the other way. They've had so many years of so many problems, and it's gotten so expensive because of the troubleshooting, and they have failures. It's gotten so expensive to operate these things that their budgets were cheaper with a chill water system and a chiller than it was to try to keep these things online long term. The longevity wasn't there. It's pretty interesting conversation to see happening. Kind of watch from the background. Let's see, so 4 years. All right, looks like everybody's just chatting away. Okay. Well, if everybody's good, hopefully you enjoyed your lunch. Thanks for tuning in. Our team, you know, we'll do this another 2 weeks, so be looking for that. I am interested in hearing some feedback from y'all on how the whole webinar thing's going. It is not our final plan, but I think that this has worked out fairly well, and we're going to see how far we can maximize this time. So anyway, y'all have a good one. I will catch y'all later.